So today is a very important day. Today we are talking about the unit circle. This whole packet I gave you is going to walk through where this thing comes from. A lot of this is just background, but the more you know, the better you'll understand. This is kind of a guided notes. There's a lot of stuff that I want to say and I would like you to have written down, so I just typed it out for you. So I will be reading some of this to you as we go. First off, what is the unit circle? The unit circle is a circle with a radius of 1. We established that earlier. There are special relationships that are formed as a consequence of it. We will explore these relationships in these notes. So, the very basics. We're starting with the special triangles. You should already be familiar with these 3 special triangles. So let's fill these in real quick. First we have the 30, 60, 90, where 30 would be our alpha. And we already know these side lengths. Across from the 30 we have 1. Across from the 60 we have square root 3. And then the hypotenuse is 2. Next we have the 45, 45, 90. And we'll let this bottom 45 be the alpha. Both sides have a length of 1. Hypotenuse is square root 2. And then we do need to look at both versions of the 30, 60, 90 triangle. So we'll have the 60, 30, where the 60 would be alpha. And these sides are going to flip. We have 1 on the bottom, square root 3 on the side, and 2 as the hypotenuse. So that should be information you're already familiar with. To put these triangles in terms of the unit circle, the hypotenuse must have a length of 1. If we look at the unit circle real quick, we can form triangles out of all of these radii, radiuses, and they all have a length of 1. So we're trying to create those triangles. So our hypotenuse in our first triangle is 2. Now we're trying to create a proportional triangle. To be proportional, what can I do to this 2 to turn it into a 1? Divide it by 2. That will give me the required side length of 1 for the hypotenuse. So we have to apply that evenly to the entire triangle. So we're dividing that whole triangle by 2, every single side. So on the right side here, that becomes a half. And on the bottom, that becomes square root of 3 over 2. Let's do that again for the 45, 45. Once again, our hypotenuse is square root of 2. What do I need to divide by this time to get 1? Square root of 2. So that becomes square root of 2 divided by the square root of 2, which gives us the 1 that we needed. On both sides, that's going to give us 1 over square root 2, which you know is not allowed, no square roots on the bottom. I'm not going to write out the work, but you know we multiply top and bottom by square root of 2. We end up with square root of 2 over 2. Same thing is going to happen on the bottom. So those are our 3 new sides for the 45, 45, 90. And let me fill those angles in again for reference. In our third triangle, we're just repeating what we did the first time, but these 2 sides are going to be flipped. So once again, we're dividing by 2. So I'll end up with 1 on the hypotenuse, square root of 3 over 2 on the right side, and a half on the bottom. This time 60's at the bottom and 30's up top. We need these triangles. They're going to be the foundation of creating the unit circle. Next page. Now we're going to take these triangles and translate them over to the unit circle, starting with quadrant 1. Quadrant 1 is something you need to know by memory. If you know quadrant 1, you can get the entire circle from there. So we're going to start again with that 30, 60, 90. And we know its side lengths. Hypotenuse is 1. The bottom is square root 3 over 2. And the side is a half. Now let's put this on the circle where it goes. This angle right here is 30 degrees. So we're going to go up to the first line. That's 30. And let's create this triangle here. The bottom side is square root 3 over 2. The right side is a half. And we're getting a point here, x comma y. Devin?
1, 1.
Not 1, because the 1's a hypotenuse, the diagonal.
Oh.
So we're looking horizontal and then vertical.
Square root 3.
Yes. Good. Square root 3 over 2. The y is a half. It's the size of the triangle. So that is our first point here on the circle. Square root 3 over 2, 1/2. And we already know that this is 30 degrees. 30 degrees is what in radians? Perfect. 1/6 pi, pi over 6, however you want to write it. That is correct. Let's do that again. Middle triangle, this is the 45, 45, 90. And we have side lengths. 1 is the hypotenuse, and the sides are square root 2 over 2. "45 degrees will take us up to the second line. And let's create this triangle here. Once again, our sides are square root 2 over 2 on both. So our point here, xy, is square root 2 over 2, square root 2 over 2. We can fill that in on our unit circle. Square root 2 over 2. Square root 2 over 2. Let's fill in the degrees. We know this is 45 degrees, which is how many radians? Pi over 4 is correct. Good. And we'll do that one more time to get to the third point there. We have the 60, 30, 90. And that gives us side lengths, 1/2 on the bottom, rad 3 over 2 on the vertical, and of course the hypotenuse is 1. Let's draw our triangle here. This time we're going all the way up to the third line there. That's 60 degrees. Creating our triangle. Bottom is a half. Side is square root 3 over 2. So the point is 1/2 square root 3 over 2. Let's fill that in on the unit circle. The point up here, 1/2 square root 3 over 2. And we already know that's 60 degrees. And in radians? Pi over 3. Good. Hopefully you're already very familiar with the quadrantals, the right side of the x-axis and the top of the y-axis, and then in between. If you can memorize these values, you've got the rest of the circle down. Quadrant 1 is extremely important. Let's fill in the other quadrants. Since everything is 1 unit around, this is just going to take a series of reflections to find the missing points. So let's start again in quadrant 1, and we'll rewrite those first 3 points. So that was square root 3 over 2, a half. Square root 2 over 2. Square root 2 over 2.
Which one do you do first?
What do you mean? Like the rad 3 over 2 versus the half? Or?
Yeah.
That is a memorization thing. It comes from the angle relationships that we just discussed. Otherwise, memorize. I personally think of the distance x versus y. So like the lower point is further to the right and not as high. Whereas this point for the 60 degrees is higher up, so we're going to switch these. The y will have the larger value. I hope that helps.
Yeah.
Kind of, yeah. It's, again, everyone kind of finds their own way to memorize this. So our third and final point, 1/2 square root 3 over 2. To fill in quadrant 2, we can reflect the points in quadrant 1 over the y-axis. We will change the signs on the x values since x is negative in this quadrant. So we're just going to copy paste. So reflecting the 60-degree angle over, we end up with negative 1/2 positive rad 3 over 2. Left side of the x-axis, negative numbers. Flipping the 45-degree angle, we have negative square root of 2 over 2, positive square root of 2 over 2. And flipping the 30, we have negative square root of 3 over 2, positive 1/2. Let's copy down these 3 new points onto our unit circle. Negative 1/2 square root of 3 over 2. Negative square root of 2 over 2. Positive square root of 2 over 2. Negative square root of 3 over 2. Positive 1/2. We'll get back to degrees and radians later. If you're already thinking about those things, that's great. If you're not there yet, that's fine. Quadrants 3 and 4, same process. I'm going to start by rewriting the quadrant 2 points. So again, that's negative 1/2 square root 3 over 2. Negative square root 2 over 2, positive square root 2 over 2, negative square root 3 over 2, positive 1/2. Now we're going to do 2 different reflections to fill in the rest of the circle. First, to get quadrant 3, we'll reflect the points in quadrant 2 over the x-axis to get those sets of points. So I'm going to reflect the 30 first. So when I do that, the numbers will be preserved, but the signs will change. When we go into the third quadrant, this is now where x and y are both negative. So this is negative square root 3 over 2, negative 1/2. Flipping the 45. This is negative square root 2 over 2, negative square root 2 over 2. And flipping the 60, negative 1/2, negative square root 3 over 2. So once again, the numbers aren't changing, it's just the signs. We have to think about that as we go into each quadrant. I'm going to recopy these onto the actual unit circle. Negative square root 3 over 2, negative a half. Negative square root 2 over 2, negative square root 2 over 2. Negative a half, negative square root 3 over 2. We'll do that one more time to get quadrant 4 points. I'll reflect the 30 first, or sorry, this is the 60. Now this time I'm in quadrant 4. X is positive here, but Y is negative. So this is positive a half, negative square root 3 over 2. Reflecting the 45. This is positive square root 2 over 2, negative square root 2 over 2. And reflecting the 30. This is positive square root 3 over 2, negative a half. Hopefully this feels repetitive, that's the goal. Let's fill these in real quick. I'm going to go top to bottom. Square root 3 over 2, negative a half. Square root 2 over 2, negative square root 2 over 2. Positive a half, negative square root 3 over 2. Questions up to here? Just to kind of give you an idea what the end goal for you is. The end goal for you is to memorize the unit circle. All the points, all the degrees, all the radians. So again, this background is just helping you understand where this comes from, but that is it. You won't be tested on triangle to circle. Just for you guys to be able to understand the connection is all I want here. But your end goal is to have this memorized. And in explaining this to you, I'm also showing you ways you can kind of make these connections in case you forget. That's all the points. Let's go back and revisit the angles, both in degrees and radians. The degrees are pretty intuitive, and so are the radians. Let's revisit the main three. First quadrant. First line, that's 30 degrees. Second line, that's 45. Third line, that's 60. Again, you can memorize the other 9 values, or you just remember the relationships. You'll be able to calculate them by hand every single time. So let me label the quadrantals. Starting on the right, we have 0 degrees, which is also 360. At the top, we have 90 degrees. On the left, we have 180. And on the bottom, we have 270. Those you'll want dedicated to memory. Quadrant 2. So the points reflect, so do the angles. This distance here is 30 degrees. This distance here is 30 degrees. So to get our first angle here, it's 180 minus that. 180 minus 30. That gives us 150. Same thing, this here is 45 degrees. So 180 minus 45. That's 135 degrees. And this is 60. 180 minus 60. That's 120 degrees. Should be recognizing a lot of this. This is what we were working with the whole time. You just didn't realize it at the time. Third quadrant, same thing. To the first line, that's 30 degrees. Now we're 180 plus the amount. So 180 plus 30, that's 210. To the second line, that's still 45. So 180 plus 45, that's 225. And to the third line, that's still 60. 180 plus 60, that's 240. Lastly, the fourth quadrant. We're going to do that one more time. From the x-axis to the first line, that's still 30. This is just shy of a full circle. So this is 360 minus 30 for the first angle. That's 330 degrees. To the second line, that's 45 degrees. So 360 minus 45. That's 315 degrees. And to the third line, that's still 60 degrees. So 360 minus 60, which gives us 300 degrees. So let's go back in and fill those in on the actual circle. Second quadrant, I'm going to go around in the counterclockwise circular direction. We have 120, 135, and 150 in quadrant 2. Quadrant 3, we have 210, 225, and 240. And quadrant 4, we have 300, 315, and 330. Once again, you're more than welcome just to dedicate those numbers to memory, but that is a lot on top of everything else you're memorizing. So just knowing the math behind it, you'll get there just fine. Questions on getting the degrees? We're going to repeat that, but in radians, which sounds painful, but you're going to find radians have a very distinct pattern, so those are actually very easy to memorize. Same thing. First quadrant. To the first line, that's 30 degrees, which is pi over 6. To the second line, that's 45 degrees, which is pi over 4. And to the third line, that's 60 degrees, which is pi over 3. So I'm going to repeat all of these calculations in the other 3 quadrants except completely in radians. Before we do that, let's label our quadrantals. On the right here, this is 0 or 2 pi. At the top, pi over 2, that's 90 degrees. On the left, that's 1 full pi. On the bottom, that's 3 pi over 2. Quadrant 2. All of these lines are just shy of a full pi. So it's going to be pi minus those amounts. We'll start with the pi over 6. First angle here. This is pi minus pi over 6, 1 pi over 6. We'll adjust this, 6 over 6. That's going to give us 5 pi over 6. Second line, that's 45 degrees, pi over 4. Again, that's pi minus 1 pi over 4. So it's 4/4 minus 1/4, which is going to give us a nice 3 pi over 4. One more time for that quadrant. This is 60 degrees, pi over 3. So pi minus 1 pi over 3. So this is 3 over 3 pi. And that's going to give us 2 pi over 3. This has a very clear pattern from a memorization standpoint. If we reflect these fractions from quadrant 1 to quadrant 2, notice the denominators are the same. So there's your starting point for memorizing. From there, we're 1 shy of a complete pi on all of these. So you take your denominator minus 1, you now know how many pi's it is. So 3 minus 1, that's 2. 4 minus 1, that's 3. 6 minus 1, that's 5. Those are very easy to memorize if you dedicate the pattern to memory. Next quadrant, we're going just 1 past pi. Another clear pattern to be made here. So first up, we have 30 degrees, which is pi over 6. It's pi plus that amount. Pi plus 1 pi over 6. So we're going to put this in sixths. That's going to give us 7 pi over 6. We're just adding 1. 45 degrees, pi over 4. So this is pi plus 1 pi over 4. So this is 4 pi over 4, giving us 5 pi over 4. One more time. This is 60 degrees, pi over 3. So pi plus 1 pi over 3. So this is 3 pi over 3, which gives us 4 pi over 3. So we're going 1 past the full pi. So you take your whole pi, which is your denominator, 6, for instance, and you add 1, you get 7. 4, add 1, you get 5. 3, add 1, you get 4. Very easy patterns to help you memorize these. Last quadrant. Now, this time we are just shy of a full circle. So, this time we're going to take 2 pi minus our number. I'm going to write that down. And I'm writing it there because I'm converting 2 pi every time. I'm not going to write 2 pi first and then convert. I don't have the space for that. So, this is minus pi over 6. So for 2 pi, I double 6. That's 12 pi over 6. 12 pi over 6 minus 1 pi over 6. That is 11 pi over 6. Next, the 45, pi over 4. This is minus 1 pi over 4. To make 2 pi, I'm going to double. We'll go 8 pi over 4. Minus 1 gives me 7 pi over 4. And for the very last time, this is 60 degrees, pi over 3. So we're subtracting 1 pi over 3. 2 pi is double 3, so that's 6 pi over 3. And we're just going down by 1, so 5 pi over 3. Reminder, in this quadrant, we're 1 shy of making a full circle, which is 2 pi. So you double your denominator and subtract 1. Double 6, that's 12, minus 1 is 11. Double 4, that's 8, minus 1 is 7. Double 3, that's 6, minus 1, that's 5. These patterns will make memorizing the radians part extremely easy. Let's go back to the unit circle and fill these in real quick. You must know the degrees and the radians. 120 degrees is also 2 pi over 3. 135 is 3 pi over 4. 150 is 5 pi over 6. Quadrant 3. 210 is 7 pi over 6. 225 is 5 pi over 4. 240 is 4 pi over 3. Final quadrant. 300 is 5 pi over 3. 315 is 7 pi over 4. 330 is 11 pi over 6. Bless you. These final two blanks up here, that's the full circle. So those other numbers, 360 degrees or 2 pi. That is the complete unit circle, fully explained how we get it, where all those numbers come from. We do have one more very important thing to discuss, so let's go to the final page. That is the all students take calculus thing. So we can go back and fill out later, but that's what that is. All right, lastly, the big thing we're building to, the important relationships, and these relationships are going to help you through your rest of your time in pre-cal, and if you want a calculus, these rules are going to be mainstays. One more time, let's revisit those first three triangles. (30, 60, 90). Hypotenuse is 1, bottom is rad 3 over 2, side is a half. We're going to find the three trig functions with those. So you can think of this as your alpha. This time we're actually going to put a number in there. So sine of 30, cosine of 30, tangent of 30. Let's label the HOA. Hypotenuse is 1. O is the half, the vertical, and the A is the horizontal. Sine is O over H. That's a half over 1, which is just a half. Cosine is A over H. That's rad 3 over 2 over 1, which is just rad 3 over 2. So I'm not changing anything if you're noticing. Tangent, these get a little ugly, just an FYI on that. This is going to be a fraction bar. Tangent, O over A. That's 1/2 over square root of 3 over 2. I don't have space to write this down, but this is an algebra trick I'm about to use. If you have a fraction over a fraction and their denominators match, they actually just cancel. So now our new fraction is 1 over rad 3. Again, I'm not going to show the math behind this, but times rad 3 over rad 3, and you get rad 3 over 3. If you're paying attention, this is where you're going to pick up on a connection. The point on the circle at 30 degrees is rad 3 over 2, 1/2. If you see it, don't say it yet. We'll get to that in a moment. Let's quickly do that for the last two triangles. 45, 45, 90. Sides 1, rad 2 over 2. Rad 2 over 2. Once again, our alpha here is 45. H, O, and A are in the same spot. Sine, O over H, rad 2 over 2 over 1. So just rad 2 over 2. Cosine, A over H, rad 2 over 2 over 1, which is just rad 2 over 2. Tangent, not pretty. This one's prettier. O over A. Rad 2 over 2 over rad 2 over 2. Don't overcomplicate it. What does that equal? 1. You divide a number by itself, it's 1. And reminder, the point on the circle at 45 degrees is rad 2 over 2, rad 2 over 2. We'll do that one more time. 60, 30, 90. 60 is the alpha here. Hypotenuse is 1. The bottom is a half. The right side is rad 3 over 2. H, O, and A have not moved. Sine, rad 3 over 2, over 1. Cosine, half over 1, so half. Tangent, this one's prettier. O over A, rad 3 over 2, over a half. Denominators cancel. It's just rad 3 over 1, which is rad 3. That point on the circle is a half rad 3 over 2. Finally, the big thing we've been building to here. Look at the point on the circle and look at the trig values. Does anyone notice anything peculiar?
Cosine and sine.
Yes. Cosine is the x value, not a coincidence. Sine is the y value. So the big conclusions here, please write these down and then we're done. On the unit circle, x is equal to cosine. Y is equal to sine. This one you won't get until I show you, so I'm going to show it to you. This is a golden rule. Tangent is sine over cosine, which is also just y divided by x, however you want to remember it. If you look back at the previous calculations, you'll clearly see that that is the case. All we do is divide sine by cosine, we get tangent.